Hello again. In our first two presentations on decision support tools for climate resilient ag, we looked at weather-driven models for predicting crop and pest development and saw some examples of packaging those models into decision support tools. In this presentation, we'll look at some of the options for continuing to improve decision support tools and discuss some of the opportunities made possible by recent advances in the underlying technology, data, and science that tools like these are based on. The ultimate hope, of course, is to give growers the best possible information in the best possible formats to deal with what seems to be increasing variability and unpredictability in our weather. So what are some of these changes I'm referring to that have opened new doors for us? On the technology side, we've definitely seen over the past decade some pretty amazing advances in web technologies and infrastructure. Everything from the tools we use to build and design the look and feel of a website, build in interactivity, the speed, the integrations, the number of companies that support different elements of a web stack. And open source technologies haven't been left behind at all. Today, many of the open source choices rival and in some cases surpass their commercial counterparts. The sources and accessibility of data also continues to expand. Look at the proliferation of weather data and weather data products as an example, by both private and public providers. Storing and delivering data has also gotten faster and cheaper through all manner of data storage and transfer technologies. The landscape of options for building a decision support tool today is very different than what we had to work with 20 years ago. Mobile devices are also getting more powerful, both on the hardware side and their software capabilities, especially mobile browsers, which today have many capabilities that you used to only see in native apps. Accompanying this growth is an expansion of broadband, which is definitely still not universal, but continuing to expand even in rural areas. On the farm side, growers are getting more sophisticated, which is good because the industry itself is getting increasingly technical, including the equipment, the service providers, and marketing needs. And driving a lot of this is ongoing, if not increasing, variability in weather. You definitely can't assume that the weather you experienced as a kid or even 10 years ago is going to be what you get this year. And that has all kinds of implications for how you manage a crop. All of which is to say, in full fairness, that the next generation is really already here. There's been a lot of progress, and we just have to figure out how to leverage these opportunities to provide better information to growers. So to make this more concrete, let's take a look at this fairly typical calculator and then think about how we might improve upon it. This is a weather-driven pest predictor that predicts when you could expect to see new generations of navel orange worm in almonds or pistachios. Typically, the user will select their location, in this case by clicking on a map, and then selecting the pest-host combination, the biofix state, and potentially their preferred source of weather data. Then they click Run. The calculator will grab some data online, either raw or pre-computed, and show different outputs like these. In this case, we have a graph of accumulated degree days with drop-down lines for the predicted flight dates, and the table with essentially the same info. It's a pretty simple design and fairly simple to use. So a few things off the bat on how we can make this the best possible decision support tool is to apply some best practices for the user interface and user experience. We know that many growers are using mobile devices. Our analytics tell us that. And there's proven methods to make sure that our web applications are responsive, meaning they fit the size of the device nicely. Things don't spill off the page or have crazy scroll bars. That we use phone-friendly HTML widgets because you can't click on things on a touchscreen, right? You can't use hover text, and what you can and cannot do is different than what you could do with a mouse. We want to use phone-friendly styling and come up with phone-friendly outputs. A lot of the standard HTML outputs for interactive tables or interactive plots, they might work on a phone, but they're definitely not optimized for phone experiences. We can definitely also provide some usability enhancements, such as making these things multilingual, using cookies so that when somebody uses it the next day or the next week, some of their input values that probably don't change will stay the same, so they don't have to reset every single box every time. Something like your irrigation rate of your system, that's probably not going to change. You can do things like add tour buttons to make it possible to bookmark the state. So in other words, save that current state so you can come back to it. To customize the appearance, make the font size bigger or smaller, dark mode or light mode, a button to add an icon to the desktop and so forth. Right? So a lot of this is very well established. We should also bulletproof the user experience. This is a big pain point, and it's something that could make somebody not want to come back to use your app. There should be plenty of help text that helps people work themselves through it. A tour function would be useful. Errors that are caused by the user error need to be trapped and given helpful messages. That's really critical. There's nothing more frustrating than getting a weird error message that you don't understand, including errors on the server. Whenever you see the endless spinning wheel that never goes away, or some message that something is broken on the back end, we should have no tolerance for that. That's like failing your driver's exam by going through a stop sign. It's automatic F. We have to figure out how to fix these things. They're not trivial to fix either. There's a lot of things that can go wrong building these things. So all of this is pretty well established and well developed, but it does require actual testing with actual users. And sometimes we need to build that into our work plans. Let's talk about the data that power these apps, because garbage in, garbage out. Your results are only going to be as good as the quality of your data. So typically in a lot of these tools, if they're weather driven, there's as many as 4 sources of weather data, right? So the recent observed weather, right? So from the start date of the beginning of the season or the biofix date to today would be one. Usually we can get a 7 to 14 day forecast, so a short-term projection. But if you're doing this in May and the harvest isn't going to be until August, you're going to need to go beyond that. So what do you do for that period, the rest of the season? Use a historical average. And in some cases, some of these apps will display a comparison, so the person can see how is this year compared to other years. So for the start date to yesterday, the recent data, a lot of apps are using commercial or publicly available weather providers, but on-site data is in some cases available and should be supported. Regional networks of like commercial weather networks occasionally will have a conglomeration of available data for their users, or maybe public. There might be other public sources of data. CIMIS is popular in California because it is designed for agricultural purposes. That being said, though, they're not everywhere, and some of them, there are issues with the biases that some of those data sets present. There are also interpolated products. CIMIS has an interpolated product called Spatial CIMIS. GridMet and Prism are 2 other ones, and there are others out there, right? But there's choices there that we can look at for getting the best possible recent weather data. For the next 10 days, there's commercial providers. There's the National Weather Service, which is what a lot of people use, either directly or a derived product. FRED is the Forecast Reference ET. That's another product, I think, by NOAA. So there might be some better options for the short-term forecast. For the rest of the season, historical averages are increasingly not the best choice because history is no longer reliable. So NOAA has a product for a 1 to 3 month forecast. There's a version of that that's already been downscaled. Another option would be to give the user the option to select a recent year that it resembles this current season. That could be automatically selected. What recent weather year is most statistically similar to how this season is getting started, or make that a user choice. So these might be some options to look at. For the historical comparison, we have more and more options there as well. There's Livni and GridMet. They're fed by CalAdapt already. Prism has 2 data products. So some of these might be possible as your kind of historic comparison, or you let the user pick that. Let's talk about the output formats. Right now, a lot of these applications will give you what you see is what you get. So you have a nice table, a nice graph. I have seen a lot of times there might be an option to copy to the clipboard, maybe to download, if it's a table, to download that as an Excel file or CSV file. I don't use CSVs anymore. Sometimes there's a print button. So these are relatively standard, not hard to implement. Some other choices, though, that we see in other types of apps would be, can you email this to myself? Can I generate a report and email me the link, or display the link that I can click on it? Maybe open up a PDF so that I can have it or send it to my team. Maybe these things could be opened up in Google Sheets. These days it's not hard to build in these integrations. There might be other calendar services or other kind of like farm dashboards or scheduling dashboards or information systems that could be integrated with your decision support tool. The gold standard is probably, share your data, whether it's a table or a graph of some sort, an infographic, with any registered application on your device. A lot of apps have that now. Let's talk about uncertainty, because these models do have uncertainty. We all know that. There's definitely going to be uncertainty in the biofix, right? That's going to usually be a range. Might just be a couple days, but you never know. There's going to be uncertainty associated with the degree to which the weather data that you're using in the tool is actually based on, or actually reflects, the weather conditions in your field or your orchard. If it's on site, that might be small. If it's farther away, it could very well be much farther. If it's a CIMIS station that's measuring temperature and humidity and evapotranspiration in an open field, that might look really different than in a canopy, an orchard that's under full canopy, much cooler and moister. So there's uncertainty there. There's definitely the uncertainty about the future weather for the next 10 days and the rest of the season. So there's some uncertainty there. The models of development also have uncertainty. You can go back to the original papers and look at the spread. It might be small, it might be large, but all of these are different types of uncertainty, and they all add up to uncertainty in what you're providing to the grower. So can we put some margins on there? Say, you expect to see little bugs crawling around. It's a good time to spray, plus or minus 2 days, plus or minus 5 days. We can start to put some error bounds around these predictions. Currently, a lot of the apps are what I would say unidirectional. They're relatively easy to build, easy to use. You go to a website, you query some data, you get information, right? So it's kind of top down. Up in the cloud somewhere, there's a brain, and that brain is accessing different types of data, weather data, maybe the models, maybe some other data. But we've also seen it's possible. It's not a minor lift, but it's also possible to make these kinds of tools multi-directional. So it's not just contributing. It's not just one directional. So could there be options for a user to share their biofix date when there's maybe some feedback on the prediction of the results? A lot of apps go viral because they provide an opportunity for open-ended chat. We see that with a lot of citizen science apps. People like that. Not saying that growers would like that. They're special and private, but maybe. And there's options to think about and ask growers if they would be interested in sharing their data with researchers. Because if we can improve these models, if we can improve our biofix estimates for a whole county, a whole part of the state, everybody's going to benefit. Maybe sharing their feedback, or their biofix results with peers, maybe anonymously, maybe pre-approved peers, and so on and so forth. There's a lot involved here, technology and building trust and making it doesn't make sense, but looking at some of these options for multi-directionality would make these apps a lot more powerful. Dealing with some of those sources of uncertainty is also worth thinking about. If somebody does manage to save their actual observed events compared to the predictions, as you build up a history of that, you might see a pattern. It might be overestimated, consistently overestimated, or consistently underestimated. So if the apps can build that in, it might give growers some information to see if these predictions actually hold water for them or not. Anonymous sharing with neighbors, again, can also be a way to help sort of calibrate or incorporate additional information to help someone decide how to interpret the information they're seeing. All right. And this could be done anonymously, and there could be, conveyed in user-friendly terms. Like, in the past 2 weeks, 3 other people within 20 miles of you have reported a biofix event for what you're interested in, and so on and so forth. Right. So we also know technology and decision support tools aren't for everybody. People just may not have the interest or the patience. So are there low-tech options that we can also look at? We all like SMS alerts. You subscribe to it and you get the message and you don't have to think about it. That's possible. These same back-end tools can provide these kinds of alerts. The old school degree day accumulation tables, there might still be a need for those. And then, a lot of tools today have an advanced and beginner mode. Some people just want to see a red light, green light. Other people might want to see all of the details and have options to integrate it into other things. All right, so looking at those. Integrating extension resources. This is pretty easy to do if you're using a web-based decision support tool. Web technologies allow to easily bundle video or written extension materials, like a little video tutorial, links to guides, the background, the technical how-to that can be built in. And then, but a big one is also like, what do you do with this information if a grower? So that's a helpful. We haven't seen a lot of that. It's also possible to provide extension resources that are tailored to how that person is using the app, or maybe some questions they put in their profile. If you want to have a profile, there can be options to make it easier for them to subscribe to alerts, to subscribe to newsletters, and to get connected to a network of extension. Currently, another pain point for the developers is there's a lot of duplication of effort. So we looked at 3 websites that are providing decision support tools on weather-driven models, and there's a lot of duplication of those. Each one, they're building their own front end, their own back end. The models are coming from published literature, so that's shared. The science is shared, but a lot of other stuff is duplicated. And part of it, that's partly because organizations are siloed, but it's also partly because they're developing tools for different audiences, and that's fine and that's expected. But a lot of the underlying infrastructure can and probably could be shared. It would certainly be more efficient for one source to grab weather data from one set of, so not everybody has to process and cache their own data. That's computationally intensive. If that can be centralized in a cooperative way, then different organizations, different providers, different individuals can tap into it through license agreements to share the cost, or other mechanisms to provide different information to different types of growers, but not reinventing the wheel every single time. All right. So that's becoming more possible. A big one that's a big pain point is just getting the parameters for these weather-driven models. They're in different places. It's often hard-coded. You also have to scrounge for them or scrape them. This could be made much more easy with a structured, machine-readable database for these different types of model parameters. We'd love to see better analytics. We don't have a very strong idea of how people are actually using these decision support tools in practice. There's a lot of good, well-developed options here. Google Analytics is easy to set up. We generally don't milk it for all you could. There's lots of possibility there. It's not difficult to log behavior of usage anonymously and with the permission of the user. But what crops, what pests are people interested? What times of years are they using it? And so on and so forth. You can ask users for feedback explicitly. Pop-up forms are easy to program. Just a basic contact us form for more information, that's easy to do. Or opt-in surveys where you would ask people to opt in to get an email survey so we can actually find out, are these results useful to them or not? There's a lot of information that we could do better collecting. So in summary, there's a lot of choices available to us to improve decision support tools and phase in another generation of capabilities. Some of these options are quick and easy, applying best practices, making them more robust. Some of them are much more complicated, and they're not just technical choices. They involve a lot of other building trust and education and outreach. So all of this should be developed and driven based on what growers need and want, not just because we can do it. And we will always expect to see that decision support tool providers, there's always going to be different audiences and different needs. So that can and should remain part of our goal, is to provide an ecosystem of decision support tools, but there are definitely collective interests, including not reinventing every piece of every component, making sure that we're using the best available science research and better analytics that we can all benefit from. So that's it. I hope you found this useful and maybe it triggered some thoughts. If you have a comment, please leave it in the comment section, and don't forget to subscribe if you'd like to see more of this content. Thanks.